Hello guys, very good afternoon to all. So in the last class, we discussed about the counting principles and what are the things that are involved in counting principles like rule of sum and rule of product in the counting principles which are useful for which are useful concepts for permutations and combinations. So now in this lecture, we'll be discussing about the permutations and combinations. So first of all, we'll see what do you mean by permutations. So we'll see what is permutation, how can we able to solve the permutation problems, and what are the formulas that are involved in this. We'll see all things. So in mathematics, coming to mathematics part, so what is permutation means? It is a mathematical concept which is used to determine the number of possible arrangements for a specific set of elements. It means that it is a mathematical concept. So by mathematically we are able to say how many possible arrangements are possible for a specific set of elements. Suppose if I have some say, specific set of elements, so for that specific set of elements, how many possible arrangements are there? So how many arrangements can be done? So like that, it is easy to determine number of possible arrangements. So for a given set of specific elements, it will determine how many arrangements are needed to arrange those elements, how many possibilities of how many possible arrangements are required for in order to arrange those set of elements. So that is called permutation. So and also it is also plays a big role in comparison cryptography and operations research. It means not only it is playing in a mathematical manner, and also it plays a very big role in computer science, cryptography, and operations research. So here see, the permutations are arrangements of objects in a specific order. So what do you mean by permutation? Permutation means we are arranging some objects. So what are the objects that are we are having? We need to arrange those objects in a specific order. So for that we need to have permutations. So by using this permutation concept, we'll know how to arrange those subjects in a specific order, how to arrange those type of objects in a specific order. Suppose if I am containing some objects and some objects, so we need to arrange those in specific order. It means those objects are not in correct order; they are in jumbled order. It means we need to arrange those in specific order. For that purpose, how many arrangements are required in order to arrange those objects in a specific order? That is the permutation it is saying. Order matters in permutations. So coming to permutation, order is very, very important. So uh, for every order, there are many orders for arranging those different objects. So suppose if we are having ABC, for this we are having different orders like ABC, BCA, CBA, CAB, ACB, like that. For just three elements only, we are seeing more number of orders. So for different kind of things, we will be having various orders. So in this, order is very, very important. So here we have to consider the order. So ABC and BCA are not same in this according to permutations. So according to permutations, these two things are not same. So ABC and BC are not same order according to permutation. It means they are starting with one number, it is starting with a number. It is ending with one number, it is ending with another number. So here order is very, very important. So we have to careful with the order. That's why order matters in permutation. And permutations are used in arrangements, rankings, and order. So if you want to arrange anything, or if you want to give any rankings, or if you want to give any order, this permutation is very, very important. So this permutation is used in these arrangements, rankings, and orders. Arrangements means suppose there is a table. Among the table, four persons have to sit. So for sitting four members, how many arrangements will you do? in order to sit four members. So what are the possible arrangements? What are the arrangement possibles in order for four people in order to sit around the table? In that case, this permutation is used, and also ranking. Suppose if you consider some MSET colleges or some other universities, there will be some rankings based on this permutation. By using this permutation concept, they will give some rankings to colleges or universities, and also orderings. So this is so, and also we'll see there is some basic formula for this permutation. So first one, if you want to arrange the n distinct objects, what is the basic? If you want to arrange n distinct objects, how many permutations are required? N factorial, because we are having n different objects, so you can able to replace each and every one in its position. So you can replace n minus one in n, n minus two in n, n minus three and n. Like that, we can able to arrange all the all the objects among themselves. So that's why n factorial is required. So n factorial is nothing but n into n minus 1 into n minus 2 into n power 1. So if you want to arrange n distinct objects, n factorial or the number of permutations required are n factorial. So if you are, suppose if you are having n objects, out of n objects, if I want to arrange R out of n objects, how many arrangements are required means NPR. So out of n, we are arranging R. That's why the formula for permutation is NPR. That is what here it is written. P of n comma R. That is nothing but NPR is equal to n factorial by n minus R whole factorial. So we can able to write this NPR as n factorial by n minus R whole factorial. That is the basic formula for permutations. And also we having some concepts like arrangements or permutations. So distinctly ordered sets are called arrangements or permutations. So you are ordering some sets uniquely that are called arrangements or permutations. So here see the number of permutations of n objects taken r at a time is given there. So if you are taking n permutations or if you are taking n objects or permutations with R at a time. So NPR. So NPR is the formula for permutation. So we can able to write this NPR as equal to n factorial by n minus R whole factorial, where n is equal to number of objects, R equal to number of positions. R determines number of positions and n determines number of objects. So arrangements are permutations. So we will see some examples. Suppose a mass debating team consists of four speakers. So there is a mass debate for the there is a team for mass debate. For the team, they are containing four speakers. So how many ways can all four speakers can be arranged in a row for a photo? So if they want to do, if all the speakers want to be arranged for a photo, in how many ways you can able to arrange? It means for taking a photo, four people can be arranged in four factorial ways or 4p4 factorial ways. 4p4 is nothing but 4 factorial. That is 4 into 3 into 2 into 1. That is equal to 4 factorial. It means four speakers can be arranged in 4 factorial ways. Because for taking any photo, there is no problem at all. And also here the order is matter. Suppose 1, 2, 3, 4, 1, 2, 3, 4 is one order. 1, 2, 4, 3 is one another order. Um, like that, many orders are possible. So for arranging four speakers, for arranging four speakers, we require four factorial ways or 4p4 ways. That is 24 ways. Next one. How many ways can the captain and vice captain can be chosen? So out of four, for a team, there will be one vice captain and one captain. So out of four members, there is one vice captain and one is captain. So out of four members, we need to choose one captain and vice captain. It means out of four, we have to choose two people. So that is 4p2. That is equal to 4 into 3 equal to 12. Like that, we have to go. So next example, a flutter on the horses. So there are seven horses in a race. So there is a horse competition. So out of there are in the race there are seven horses are there. So in the first one, how many different orders can the horses finish? So out of the given seven horses, they are asking how many different orders can the horse finish? Means seven factorial because there are seven horses are there. Each can be varied according to their position. So here order matters. That's why we have to consider every order as different order. So 7 factorial or 7 p7. So how many trifectas are possible? Trifecta means first, second, and third are possible. Means so on out of seven, there are how many trifectas means how many prepositions are possible means out of seven, they are asking about how many three are possible means 73. So that is 210. And also we'll see under generalized examples. So yeah, see how many ways can three students can be seated in five chairs. It means there are five chairs. Out of five chairs, how many in how many ways we can able to seat these three students in five chairs means so 5p3 because out of 5 we are using 3 out of 5 chairs we are using only 3 students. That's why we are using 5p3. It means we are using 3 arrangements. Out of 5 chairs we are using only 3 arrangements. That's why we got 5p3 ways. So 5p3 means 5 into 4 into 3 that equal to 60. In 60 ways 3 students can be seated in 5 chairs. So just generalize and take a diagram and get it. So you can able to easily solve. Next one, all are inverse. Here see, how many ways can the letter of the gate can be arranged? So there is a letter called gate. So they are asking, in how many ways can gate can be arranged? There are four. So gate can be arranged in 4p4 ways. So 4p4 means 4 factorial ways because all are distinct letters. So number of distinct arrangements can be made in permutations means n factorial. So here there are here there are four numbers are there. So four alphabets are there. So that's why 4 factorial that equal to 24. Next one. So permutation with repetition. Suppose we are using permutation concept. So in that some of the alphabets are repeating. So if they are repeating, how to solve? The formula for the permutation with repetition is n factorial by p1 factorial into p2 factorial into pk factorial. Where p1 factorial is number of same alphabets the number of same alphabets of p1 in n factorial, number of same factorials number of same elements of p2 in n permutations and so on like that. So here see, I will explain. Here see how many ways to arrange level. So there are five letters. So out of them, how many how many in how many ways we can able to arrange this um, level? It means out of five there are already four letters are repeated. So what is the formula n factorial? N factorial by. So 5 factorial by. So P1 factorial. Suppose I am taking L as P1. So how many L's are there? 2. 2 into factorial into. Next one. Which is repeated? E. E is repeated. So E is taken as P2. So 2 factorial into how many E's are there? 2 E's are there. So E into E. Sorry, 2 into 2, 4. So 5 factorial means 120. So 120 by 4 equal to 30. Like that, we have to solve each and every problem. So we will see some other examples also. Okay. And also there are some there- permutations with restrictions. It means there are some restrictions which can be seen in permutation. We will see that. So see one example. How many ways can five boys and five girls? if there are no restrictions. Suppose there are no restrictions, they are asking in how many ways we can able to arrange these five boys and four girls on a bench. It means how many students are there total? Nine students. Nine students. In how many ways we can able to arrange? It means they are all distinct students. So there are no repeated students. So it is permutation with a distinct object means it is n factorial. So we can able to arrange those five boys and four girls in 9 factorial ways or 99 ways. It means out of 9 students, we can arrange those 9 students in a bench in 9 ways. That's why it is 9 finite or it is 9 factorial. Next one. If boys and girls are alternate, suppose there is one boys and girls should sit alphabet, then how many ways you can sit? So there are five boys and four girls. So you can able to see one by one girl, one by one girl, one by one girl, one by one girl, one by. So in how many ways you can see how many ways in boys are arranged one, two, three, four, five. Because these five positions can change. So this week will replace this week, this will be replaced with this. Like that, these five boys will can change and the order also matters. That's why it is for 5 factorial into next one. G. There are four Gs. So these four Gs can be varied with respect to their position because this G can be varied to this position, and this position. This can be varied this position, this position, and this position. This can be varied this position, this position. Like that, four Gs can be found. Four Gs can be arranged in 4 factorial ways. So that is 5 factorial into 4 factorial. Or we can also say out of 5, we can able to arrange these 5 bytes in 5 ways. So 5p5 into 4p4. So this is the restriction. It means out of having the number of students, how many we can able to arrange in such a way that these should not sit together, they should not sit together. Those are the restrictions. So that is the permutation with restrictions. See next example. In how many ways can 5 boys and 4 girls? So like that you can able to solve this problem. So see the um, see the next question. I mean, how many ways can 5 boys and 4 girls can be arranged on a bench? If it means there are 5 boys, there are 5 boys and 4 girls. So they are asking in how many ways we can able to arrange the 5 boys and 4 girls if boys and girls are in separate groups. There are two groups. It means boys and girls. So if they want to they are asking how many ways we can arrange these 5 boys and 4 girls if they are in separate groups. It means boys are in boys groups and girls are in girls groups. So you can do these groups like this: boys and girls and or girls and boys. You can do this. So if I do boys and girls means in boys group I will get 5 factorial. In girls group I will get 4 factorial. Plus R means you have to do plus. So if I do first one girls group means it means we have to go with 4 factorial into next boys group means 5 factorial. it is changing the order. That's why here order is matter. So in boys and girls group we can see 5 factorial into 4 factorial. But coming to girls and boys means we see 4 factorial into 5 factorial. So like that we can able to solve. Or you can able to solve 5p5 into 4p4 into 2. So how it is 5p5 into 4p4 into 2 means 2 is for group. So how many groups are there? There are two groups for boys and girls. So that's why you have to into 2. So how many boys are there? 5 boys are there. In how many ways we can able to arrange? In 5p5. 5p5 into. Next, how many girls are there? 4 girls are there. How many girls? In how many ways we can able to arrange those 4 girls means 4p4, that is 5p5 into 4p4 into 2. So that is the thing happening in this. Next, Anna and Jim wish to stay together. So A and J wish to sit together. So A and J means how many elements are there? Two elements. Two into next one. Out of nine, we are making two. We are making two. That's why two. These two can be considered as one group. So consider it as one. Next two, three, four, five, six, seven, eight. So how many possible ways are there? Eight possible ways are there. So that's why into 8 factorial or 2 into 8 p 8 power. 2 into 8 p 8. Because why it is included means they are asking about only A and J. That's why I am to stay together. So whenever you do this together, you made A and J as the one group. So remaining as separate one. So consider this as one. So consider this as a group. So separate it. So one. So this will be treated as one, two, three, four. Like that, we are having eight permutations. So we can do eight. It means we can able to do eight arrangements, eight factorial ways. So and they stay together. So how many people are there? Two. That's why two into eight factorial. That is. So arrangement with repetitions. So suppose if we are having n elements of which x are like of one kind, y are like of another kind, z are like of another kind. So suppose we are having n elements. Out of n elements, we are x is one, x is like of one kind, y is like of another kind, z is like of another kind. So the number of order selections or number of permutations are given by n factorial by x factorial into y factorial into z factorial. As I have seen in this last example. See here, how many different arrangements of the word paramatta are possible? You are giving paramatta. So how many letters are there? 10 letters are there. But there are some letters repeated. So see here, how many A's are there? 4 A's are there. Next two R's are there. Next two T's are there. So in how many ways you can able to do this arrangement? N factorial. N factorial means how many letters are there? 10 factorial by how many fours are there? How many A's are there? Four. So 4 factorial. Next, how many R's are there? Two times R is repeated. That's why it is 2 factorial. And how many times T is repeated? Two times. That's why it is 2 factorial. So after solving this, we got this answer. So that is next one. Next example. How many arrangements of the letters of the word remain are possible? So there is a letter called remain. So they are asking how many arrangements are there possible if there are no restrictions. Suppose there are no restrictions, they are asking. So whenever you see no restriction, you can able to see how many distinct number of possibles are possible by using this. So whenever you see the distinct, you can have to go with factorial. So how many letters are there? Six. So you have to go with six factorial, or you have to go with 66. So whenever you see no restrictions, you have to go with n factorial. Suppose if they are begin with RE, so it should begin with RE. It means these two positions are fixed. So after that, after fixing these positions, how many how many more possible ways are there? Four. So they are asking in how many ways we can do arrangement. So one, two, three, four. So out of them, we can able to do 4 factorial ways because they are started with RE. So they are started with RE. Already two already two places are fixed. So they are asking how many possibles are, how many arrangements are possible for this four. Don't go with 64 because already two are gone, remaining four are there. So in how many ways these four letters can be arranged in four underline word means 4p4 or 4 factorial. Like that we have to start. Let's see. They do not begin with RE. Okay. So if they don't want to begin with RE, we have to what you need to do means you need to subtract total minus begin with RE. So we have to we have to take begin with RE. Out of total, you need to do subtraction. So whenever I did begin with RE, what is the answer I got? 4 factorial. So what is the total? 6 factorial. We have to subtract 6 factorial minus 4 factorial. Then you can get, they do not begin with RE. So these are the combinations possible. These are the permutations possible. So next one you can see how many arrangements of the letters of the word remained are possible if they have RE together in order. So RE are together. It means you have to combine them and they are in order. So they are in order means you have to fill those positions with RE as a single unit and you have to consider this position as one. Next, how many are there? 4. 1 plus 4, 5. So they are asking in how many ways we can arrange the word remain in this 5. It means we can able to arrange this in 5p5 ways because this is treated as one single unit. That's why it is 1, 2, 3, 4, 5. Out of 5, how many in how many ways we can able to arrange this letter means 5p5 ways or 5 factorial ways. Next, they have REM together in any order. It means REM together. So in any order, we can able to arrange this REM or ARM or MER. So for or MERE like that. So for this, we have to make this order is possible. So for this REM, 3 factorials are possible. So 3 factorial or 3p3 into next, you need to include this as one unit. 1, 2, 3, 4. So for these four blanks, in how many ways you can able to arrange these four letters? So REM is 1. So remaining are 3. This 1 plus 3 are 4. In how many ways you can able to arrange these four letters in four blank means 4p4 ways. So 3p3 into 4p4 equal to 144. Like that you will get. Next one. REM are not to be together. It means R and EM are not to be together means what you should do means you need to do REM are should to be together. It means you can able to do they are sitting together. After that, after doing together, you need to subtract total from that. So how many total is are there? There are six letters. So 6 factorial minus. So if you do this problem with R and E, R, E and 1 are together, you will get the answer 144. Here see we got 144. Subtract that, you will get that. So this is next example. There are 6 boys who enter a boat with 8 seats, 4 on each side. In how many ways? So actually, there are 6 boys who enter a boat with 8 seats. So they are entering to the boat with 8 seats, 4 on each side. It means having 8 seats, 4 can sit on each side. Out of 6 people, in each side there are 4 people possible to. There are four possibilities to sit 4 boys in each side. So they sit anywhere. It means first question, in how many ways they can sit anywhere means how many seats are there? 8 seats are there. So out of 8 seats, there are 6 boys are there. So they can sit anywhere means 8p6 are possible. 8p6 arrangements can be possible. Next one, 2 boys A and B sit on the port side, and the another boy W sit on starboard side. It means there are 2 boys A and B. So they will sit on port side, and another boy W who can sit on the starboard side. It means A and B can be port side. It means they are two. Out of four, 2 people are on port side. That's why 4p2. Next one. Next W. And the next side, how many seats are there? Next time, four seats are there. Out of out of four seats, only one boy is sitting alone. So the number of arrangements are 4p1. So now others means remaining people can be in 5p3. Total possible number of arrangements are possible is 4p2 into 4p1 into 5p3. This is the required solution. Next example. From the digits 2, 3, 4, 5, and 6. So here we are having the digits 2, 3, 4, 5, and 6. They are asking how many numbers greater than 4000 can be found. So out of given number, how many numbers can be found? How many ways you can able to arrange the source in such a way that that number should be greater than 4000. In how many ways you can able to do? It means there are five digits, so five blanks are there. It means it is greater than 4000. Greater than 4000 means it should not. We should not start with two and three. We should start with four. Next four, we have to start. Next four, we have to arrange four numbers in four. It means four digits must start with digits greater than or equal to four. Means. So in how many ways we can able to start with? There are five. So 5p5, 5 factorial. So what they are asking, the what we have to do is four digits. The must we have to start always the digits which is greater than or equal to four. So if it is greater than or equal to four means how many numbers possible we can able to start with greater than or equal to four? Three because four, five, six only is the possibilities which is greater than 4000. That's why out of three we have to select only one. That's why 3p1. Next, how many four blanks are there? In out of four blanks, we have to arrange remaining things in the remaining blanks. It means in 4p3 ways you can able to arrange. So total is 5p5 plus 3p1 plus 4p3. So these are the possible solutions. Next one, see. How many four-digit numbers would be even? It means they are asking, suppose we are having four digits. So out of four digits, how many numbers should be even? It means if it wants to be even, it should end with two or four or six. So for the last position, how many possibilities are there? Three possibilities because it should always end with two, four, or six. Then only it would be even. So that's why it can be arranged in three p1 ways. So in one position, we have to. So there are three possibilities in one position. That's why you can able to arrange in three p1 ways into. So remaining out of four, we have to arrange in three. So 4p3. So that's why it is 4p3 into 3p1. These are the possibilities. So next one we can able to see circular arrangement. So what do you mean by circular arrangement? So we starting. So please wait 2 minutes, guys. I will start it soon. So, so, hi guys. There is a short break that I have to. So sorry for it. So let us discuss next topic, circular arrangements. What do you mean by circular arrangements? It means till now we have seen how we are arranged this, how the things we are arranged in different manner. Now, circular arrangements means how we can able to arrange those elements in a circular manner. So those type of things will be seen in this concept. So see here, circular arrangements are permutations in which objects are arranged in a circle. It means what do you mean by circular arrangement? The permutations in which we will arrange those objects in a circular manner. So arranging the objects or things in a circular manner is called circular arrangements. So now let us see this example. Consider arranging five objects around a circular table. So there are five elements. So we are arranging these five objects in a circular table. A, B, C, D, E, like that. So the arrangement is like. So you can able to arrange like A, B, C, D, E, or B, C, D, E, A, or C, D, E, A, B, E, or D, E, A, B, C, or E, A, B, C, D, like that. So this can be done in different lines. So but they are identical according around a circle. So these are the this is the circular arrangement that we can able to do. This is the circular arrangement. It means arranging these five objects in a circular manner. So here see the five objects A, B, C, D, E, A, B, C, D, E. So from that you can able to say like A, B, C, D, E, or B, C, D, E, A, or C, D, E, A, B, or D, E, A, B, C, or E, A, B, C, D. So like that we can able to do. So circular arrangements. So if you want to calculate the number of ways in which we can able to arrange the n objects in a circular means, we have the formula n minus factorial ways. So if they are asking any question, how many ways we can able to arrange these objects in a circular way means we have to take n minus 1 whole factorial ways. So those are the number of arrangements that can be done in a circle. So that is the formula. So next one, circular arrangement. See, at a dinner party, six men and six women sit at a round table. How many ways can they sit? There are no restrictions. So at a dinner there are six men and six women. Total how many are there? 12. So they have to sit in a round table. So without having the restrictions, in how many ways they can able to sit? So n minus 1 whole factorial. It means 12 minus 1 whole factorial is equal to 11 factorial. So next one, men and women alternate. Men and women alternate means first men, second woman, next men, next woman. Like that. How many ways are there? N minus 1 whole factorial into 6 factorial. That is equal to 5 factorial into 6 factorial. Next one, a circular arrangement. Next question. At a dinner party, six men and same question only. Ted and Carol must sit together. So Ted and Carol must sit together means we have to combine those two people and others can be combined in next two. So out of 12, we have combined two people. So that's why it is taken as one. And how many ways are there? 10 ways are there. So how many people are coming? Two. Two factorial into. In 10 way, in out of 12, two people were gone. So how many places are there? 10 places are there. Out of 10 places, we have to arrange 10 people. That means it can be done in 10 factorial ways. So the answer is 2 factorial into 10 factorial. Next, Bob, Ted, and Carol must get together. BTC. So like this only, we have to make and we'll get 3 factorial into 9 factorial. Next one, circular arrangements. So next one, neither Bob nor Carl can sit next to Red. It means uh, neither Bob or Carol can sit next to Ted. Means it means Bob and either Bob or Carol should not sit next to Ted. It means they should not sit beside the Ted. It means sit two of the another 92 next to Ted in 9 into 8 plus or 92. It means sit the remaining 9 people in 9 factorial ways. So 9 people should be done in 9 factorial ways. So these three people should not together. So we have to sit 9 into 8 ways or 9 to 2 ways. So the solution is 9p2 into 9 factorial. So see, in how many ways can 8 different colored bits to be threaded on a string? So, so there are two different colors. So for that, and also see here, as necklace can be turned over clockwise and anti-clockwise arrangements. It means it can be done in clockwise or it can be done in anti-clockwise. So there are two possibilities. So out of them, what we have to do is n minus 1 whole factorial, 8 minus 1 factorial, 7 factorial by, there are two possibilities. So divide with 2. So you'll get required answer. So there are unordered selections and ordered selections also there. So we will see those ordered selection and unordered selection in the next class. So I am winding up this session in this. So I think everyone got my point and everyone understood this class. So hope everyone understood. So we'll see in the next class. So until then, bye.